Today, we are breaking down a concept that's, well, absolutely fundamental in computer science, the linked list. It's this super flexible and powerful way to organize data. And trust me, by the end of this, you'll see why it's a cornerstone for so many applications.
So here's how we're going to do it. We'll start with the big picture, what a linked list even is. Then we'll zoom right in on its building blocks. After that, we'll see how to actually hook them all together, tackle a fun little challenge, and then we'll peek into the future to see what comes next.
All right, let's get right to it. First things first, what in the world is a linked list? And honestly, what's the big deal? Okay, so at its very core, a linked list is just a way to store stuff. A bunch of numbers, names, whatever you've got. But the real magic isn't what it holds, it's how it holds it. It uses this really cool, flexible, chain-like structure. Now, you've probably worked with arrays before, right? Think of an array like one of those weekly pill organizers. It's one single box with a set number of slots. A linked list? Totally different. It's more like a train. Each train car is its own box, its own container, and they're all just hooked together. And this difference, it's a huge deal for performance. Think about it. Adding a new car to the front of a train is easy, but trying to add a new slot to the beginning of a full pill box, you'd have to shift every single pill down. What a pain. So let's zoom in on one of those train cars, a single link in our chain. In the world of computer science, we have a name for that. It's called a node. And this whole idea of the node, it's the key to absolutely everything. I don't care if your list has 2 items or 2 million, it is all built from this one simple, elegant component. So every single node has 2 jobs. First, it holds a piece of data. Could be a number, a string of text, whatever. Second, it holds a pointer, basically an arrow that points to the very next node in the sequence. It's kind of like a person in a conga line, right? They're part of the dance, but they've also got their hands on the shoulders of the person in front of them, showing you exactly where to go next. And when you look at it in code, it's just beautifully simple. We make a node class, it holds our data, in this case just a number, and then a reference called next that, well, it points to another node object. And that little piece right there, where a node points to another node, that's the magic trick that makes the whole chain possible. Okay, so we've got our building blocks, but how do we get from just a random pile of nodes to a real, ordered, powerful chain? Let's do it. Just imagine we've made a few of these nodes. Right now, they're just floating around in your computer's memory. They have no idea about each other. Each one is holding its piece of data, but that special next pointer, it's empty. It's pointing to something we call null, which is really just a fancy word for a dead end. Okay, first up, let's create our very first node. We'll call it node A, and let's say we're going to store the number 6 inside of it. Then, let's do another one. We'll make node B and give it the value of 3. But for now, there's still just 2 separate, lonely nodes. And here it is. This is the magic moment. This one little line of code tells node A, hey, that next pointer you have, it's not a dead end anymore. I want you to point it directly at node B. And boom, just like that, we have a chain. We've made the very first connection. Now we can start at node A, check out its data, and then just follow that next pointer like a roadmap to get straight to node B. All right, so we get the theory, we know how to build one, but how do we actually use this thing in the real world? Let's put this new knowledge to the test with a classic little problem. So here's the puzzle. Someone hands you just the very first node in the list. We call that the head. And they ask you, how many nodes are in this whole chain? How do you figure that out when you can't see the whole list at once? Okay, before we even touch any code, let's just think through the logic. It's really just like walking down the chain one step at a time. You start at the beginning, at the head, you count 1, and then you just ask, is there another node after this one? If the answer is yes, you take a step to it, and you count 2. You just keep doing that over and over until you finally hit the end of the line. Now, let's turn that idea into code. It's pretty straightforward. We need a variable to keep count, obviously. We need another one to keep track of where we are in the list right now. And the heart of it all is a loop that just keeps on running as long as our current spot has a next pointer that isn't a dead end. Inside that loop, we do 2 simple things, move to the next node and add 1 to our counter. And once you get to that very last node, its next pointer is going to be null. That stops the loop. And at that exact moment, you look at your counter variable, and bam, it's got the final answer, the total number of nodes in the list. Simple as that. So we've pretty much mastered the basics of a simple linked list. But honestly, this is just the tip of the iceberg.
there is so much more you can do with linked data structures. Think about this for a second. There's a big limitation here. Because each node only knows about the next node, our list is basically a one-way street. Once you travel from node A to node B, there's no simple way to turn around and get back to A. You'd have to go all the way back to the start. For some problems, that's just not very efficient. But the solution is so clever and simple, it's called a doubly linked list. All we do is give each node a second pointer. We call it prev for previous, and it just points to the node that came before it in the chain. And just like that, our one-way street becomes a two-way superhighway. And that's what I want to leave you with. Think about this. What new doors open up when you can move freely through your data, forwards and backwards? How does that completely change the way you might solve a problem? That's a great thing to chew on as you keep digging into the amazing world of data structures.